Hello everyone and welcome back. My name is Mr. Kovault, and in this video I'm going to talk about how you can calculate the standard potentials for electrochemical cells by using the standard electrode potentials of the half reactions of a redox reaction. So here is an example. Here we have a redox reaction that is going on in a chemical cell, an electrical chemical cell or battery. And so the first thing we need to do if we're going to find or if we're going to calculate the standard potential for the electrical chemical cell, we need to divide this into its two half reactions, the oxidation and the reduction reaction. So first thing we need to figure out is what got oxidized, what got reduced. So the aluminum here is going from solid to a 3+ aqueous. So it's losing electrons. So that is getting oxidized. So our oxidation, so the oxidation is going to be aluminum solid going to aluminum 3+ aqueous. And then we need to balance out the equation, so we need to use electrons. So in order to get this balanced, this side is neutral, it's got 0 charge. Here we have a 3+, so we're going to have to add 3 electrons. So that way now the charge is balanced. So this is our half reaction for the oxidation. And then whatever's left over is the reduction. So our reduction equation is going to be NO3- aqueous plus H+ aqueous, and then we got NO gas plus 2 H2O liquid. And one of the things I'm noticing already is that there should be, this is not balanced, there should be a 4 here. We have 4 H pluses there, so we should have 4 H pluses there. I think that's the only thing that's unbalanced. Okay, so this is our other half reaction. This is our reduction reaction. And we could tell that reduction is occurring because here we're going from N. So here we have a -2 for the oxidation state of oxygen. We have 3 oxygens, so that's a total of a -6. And so we have a negative here, so the oxidation states together must equal the negative. So -6 plus +5. So that's a +5 there. And here, that's a -2 again for oxidation state. That's going to be a +2. So that's going to be a difference of 3. So here we're going from +5 +2. So that's reduction. We're gaining electrons. Okay, so that means we need to balance out the charge here. So we have a -4 positive. So that's a total of a 3+ here. This is neutral. So we need 3 electrons on this side. So we're going to have three electrons on this side. So we're going to make this is 0, so we need to make this 0. So that's going to have +3 electrons. Here, let's put it down here. So we'll just say +3 electrons. Okay, so now all we need to do is look up in our tables for the electrode potentials for the oxidation and reduction. So if we look that up in the table, you'll find that the oxidation, which happens at the anode, is -1.66. So this is -1.66. That's the electrode potential for the anode. And then we look for the other one at the cathode. So remember, reduction happens at the cathode. So that's going to be 0.96. 0.9. So the standard electrode potential for the cathode here for this reaction is going to be a positive 0. What did I say? 0.96. 0.9. Oops. 0.96. And so now we're going to be able to use this equation. The standard potential of the electrochemical cell is going to be equal to standard potential of the cathode minus the standard electrode potential of the anode. So cathode minus anode. And so here we have the cathode here, right? Or the cathode, oh, I should label this. Cathode. So we have the cathode, that's going to be equal to, 0 plus 0.96 minus, and this is volts, I should put volts in here, this is volts. So volts. So minus negative 1.66 volts, and that gives us a total of 2.62. So that's 2.62 volts, a positive number. And so that's how you find from the standard electrode potentials of the half reactions, your reduction and oxidation, and using this equation. So the standard potential of electrochemical cell is equal to the electrode potential, the potential of the cathode minus the potential of the anode. What is happening at reduction minus the oxidation. So I hope this was helpful. If you enjoyed this video, if you like my videos, please like, share, subscribe, hit the notification bell, make a comment in the comment section. Thanks for joining me, and I'll see you next time.